Hello everyone, I am Prabhu Ben Marad, Assistant Professor, Department of CSC BL DCT, Jaipur. In this video, I am going to discuss about manual simulation of dump truck problem using event scheduling algorithm. Solved example. Let us first define the problem statement. One company uses 6 trucks to haul a manganese ore from Kolar to its industry. There are 2 loaders to load each truck. After loading, a truck moved to the weighing scale to be weighed. The Q discipline is FIFO. When it is weighed, a truck travels to the industry and returns to the loader queue. The distribution of the loading time, weighing time and the travel time as follows. So calculate the total busy time of both the loaders, the scale average loader and scale utilization. Assume 5 trucks are at the loader and 1 is at the scale at a time 0 and stopping time is 64 minutes. So you have to consider the loading time of a truck and weighing time of a truck and traveling time. And you have to assume at a time 0 out of 6 trucks, 5 trucks are at the loader and 1 truck is at the scale, and you have to conduct a simulation for 64 minutes by using event scheduling algorithm. So according to the problem statement, so we draw the schematic diagram of the process as shown below. So out of 6 trucks, 5 trucks are at the loader. So in these 5 trucks, 2 trucks are being loaded, that is T2 and T3. T4, T5 and T6 are present at the loader queue, and 1 truck, that is T1, is at present at scaling point. So there are no trucks right now at weighing queue. So in second step, we will regenerate the given data. So that is, according to the problem statement, the truck T1 has already completed its loading and it is present at scaling point. So therefore truck T1 loading time is 0 here, we have not taken any value, and truck T2, T3, T4, T5, T6 is having a value 10, 5, 5, 10, 15, so on, and remaining 2 values, that is 10 and another 10. So these values will be taken and considered when the truck completes its loading, scaling, and after traveling and unloading the coal, when it arrives back to the loader queue, that time these values will be considered. And weighing time of truck T1 is 12, T2 is 12, so on, and truck T6 is having 16, and travel time, this is very important. So this will be considered dynamically. So that is the truck which completes its scaling first, for that it will be assigned. So in third step, we will list out the event notices, that is loading event notices and weighing event notices according to the event notice format. And whatever the event notices which we have listed out here are all considered at a time T0. So the actual happening of the event will be calculated by using the formula, that is present time plus event time. The present time nothing but the clock time, so that is added with the event time, and arrival at the loader queue, that is travel time, will be considered dynamically, as I said already. So now let us construct a simulation table. So we are using the parameters that is clock. So the clock will keep track of the simulation time, and the LQ of T is nothing but it indicates the number of the trucks which are present in a loader queue at a time T, and L of T indicates the number of the trucks at the loader at a time T. WQ of T is weighing Q. It shows the number of the trucks present at weighing Q at a time T, and W of T is weighing point, the number of the trucks which are present at the weighing point at time T, and FEL will be having the list of the event notices which are going to happen very soon in near future, and BL is a variable, a state variable, which will be holding the information of busy time of the both the loaders, and BS is a variable which holds busy time of the scaling point, and last column will list out which events which are going to complete. So at a time 0, according to the given assumption, so 3 trucks are present at loader queue, so they are T4, T5, T6, and 2 trucks are present at loading point, so they are T2 and T3, and weighing queue is not having any trucks present, and W of T will be having only one truck which is currently being scaled. So what we do, we will list out the event notices, and we will write and we will select the event notices which are going to happen very soon in the near future. So we have to consider 2 end loading events every time and 1 end weighing event, because 2 loaders are currently working and 1 scaling point is currently working. So there are 3 events which are going to happen very soon in a near future. So they have listed in a FEL according to chronological order. And right now, just now a system has been started. So the busy loader time is 0 and busy scale is also what here 0. So just now at a time 0, T1 completed its loading and T1 is present at the scaling point for weighing purpose. So next what we do, we will select a next event which is going to happen very soon from FEL, and we will advance the clock to that event time, and we will execute that particular event and we update all the parameters. So we select the next event as a what here end loading of T3 at 5. A clock is advanced to event notice. So end loading of T3 is completed, means from the loading point the T3 will come to the weighing queue, because currently the truck T1 is being weighed. Okay, so what we do, in loading point the truck T4 will move from the weighing queue to the loading queue to the weighing queue to the loader point. So truck the 2 trucks are present at T5 present at loading queue, so they are T5 and T6. And again what we do, we will list out the event notices which are going to happen very soon in a near future. Since last 5 minutes 2 loaders are busy, so therefore the busy loading time is 10 minutes and busy scale time is 5 minutes. Truck T3 has completed its loading. So next what we do, we will select a next event which is going to happen very soon from FEL, and we will advance the clock to that event time and we will execute, and we will update all the statistic values. So next event is end loading of T2 at 10. So what we do, we will advance the clock to this event notice and we will execute this event. So, end loading of T2. So, T2 will complete its loading and it will be moved to the weighing queue, right, and we will find out the next event notices which are going to happen very soon by referring the event notices table. And since last 10 minutes two loaders are busy, so therefore it is 20, and one scale is busy, therefore it is 10. So next we select a next event which is going to happen very soon, that is end loading of T4 will be completed at 10. So we will advance the clock to 10. So that is end loading of T4 will complete. So T4 will move to the weighing queue, and T6 will move to the loader point, and the loading queue is having presently 0 trucks, and the truck T1 is still scaling. Okay, its scaling end weighing has not yet completed. So what we do, again we will organize the list of the event notices according to chronological order. So next event which is going to happen is end weighing of T1 at 12, end loading of T5 as 20, and end loading of T6 at 25. So this we have written as a 10 plus 15. So the 15 is actual time taken, but how do we calculate the exact time taken for end loading of T6? That is, present time is 10 and time at which we had considered at event notices is 15. So therefore it is 25. So next what we do, we will select next event notice which is going to happen very soon, and that will be executed. So the next event which is going to happen is end loading of T5 at yes, T1 will complete its loading, and this is what here the statistical values updation. So similarly the simulation will be carried out by selecting next imminent event from the FEL, and we will advance a clock to the imminent event time, and we execute that particular event and we will update the statistical values, right. So like this a simulation will be conducted for 64 minutes according to the problem statement. The simulation ending time is given is 64 minutes. So but we shall conduct a simulation for 76 minutes. At 76th minute the status of the system, nothing but the snapshot is, that is the loader queue is not having any trucks which are waiting, and 2 trucks are present at the loading point, they are T1 and T2, and 0 trucks are present at the weighing queue, and 1 truck is present at the T6, 1 truck is present at the weighing point. So that is T6, and these are the next event which are going to happen very soon, and the total busy time of 2 loader is 49, total busy time of scale is 76 minutes. So next step is we have to estimate the busy time of the loader and busy time of the scale. So that is the utilization of the loader and utilization of the scale. So 2 loaders are since busy from 0 to 49th minute. So therefore 49 divided by 2 divided by 76. So the total busy time of the loader is 0.32%, and the utilization of the scale is 76 divided by 76, that is 100. Okay, 100% scale is busy, right. Thanks for watching the video. Please like and share the video to support us. Also subscribe to my YouTube channel to watch more videos on system modeling and simulation. Thank you.